Okay. So I could multiply this this third row by 3 and add it to the second row. That would turn that into a 1, and it keeps everything nice whole numbers. Or I could do this. What would I multiply -5 by to turn it into a positive 1? -1/5. So I could just take that second row and then multiply it by -1/5. Either one of those will turn this into a 1. Now, if I multiply this row by -1/5, this is going to be a -4/5, and this is going to be a positive 23/5. Now, those are pretty ugly fractions to work with, right? Okay. Do you like doing arithmetic with fractions? No. Shane, how about you? Do you like working with doing arithmetic with fractions? Not at all. Shane does not like that. Okay. But does your calculator care? Your calculator doesn't care. Okay. It's the same rules there. So I'm going to show you how to solve this one using the calculator again. So again, let's type this in. So I'm going to hit matrix, edit. And we're going to type in a 3 by 4. And again, I'm going to start with the original one. 1, 1, -1, and 6. 3, -2, 1, and -5. And then I've got a 1, a 3, a -2, and a 14. And again, right here, double check and make sure that we've got it in right. 6, -5, 14. -1, 1, 2, -2. And then the first two rows, we've got a 1, a 3, and a 1, and a 1, a -2, and a 3. So I've got that in there correctly. Any questions? Second quit. Clear the home screen, display that matrix. Last chance to double check and make sure we did this right. It's typed in there correctly, so I'm going to do these two commands. So I'm going to do, let's see, we grab that command, we're going to do some math. So we go over to math and hit the up arrow. I'm going to times by -3, comma, the matrix A, comma, row 1, comma, add it to row 2. Is that what we got here? It is. We like that work. We did step number 1. So we're going to save that. So we store in the matrix A. Let's do this command now. So we're going to hit second enter a couple times. We're going to recall that times row add command. This time I'm multiplying by -1, row 1. And the only two things I need to change are that constant, and I'm going to add it to row 3. Do we like the work? Does it confirm the arithmetic we did by hand? It does, so we're in good shape there. So again, I'm going to store that command, or store that answer. Okay, now, if you're using the calculator, I would multiply this row by -1/5. If you're doing it by hand, even though this is going to make bigger numbers, this number right here is going to be 24. So you're going to have to add that. That actually works out to be pretty nice. That's not too bad. Okay. But I'm going to multiply this by -1/5. So I go to matrix, go to math, hit the up arrow. Where's the command I need? Okay, it's E. So I go up 1. I tell it what I'm going to multiply by. I'm going to multiply by -1 divided by 5, comma, the name of the matrix, matrix A, comma, what row? Row 2. Okay, did that do what we want? We've got goal 1, 2, and 3. Here's goal number 4. Now I just need to focus on these guys right here. Any questions? With me? Okay. So I like the work that I did, so I'm going to store that. Now I'm going to use this, so let me cross this off because we didn't do that. Okay, I'm right here, so I did these 3 commands. Now I want to use this one to make that a 0 and to make that a 0. So I'm going to multiply row 2 by what? I either need to make that a 0 or that a 0. Multiply by -1 and add it to, if we multiply it by -1, add it to which row? Row 1. Okay, let's go ahead and do that command. Now, I've got a times row add command back here a little ways, so we'll just go back and find it. Gosh, we already have the -1 there. All I need to change is I'm multiplying row 2 and I'm adding it to row 1. Did that do what we want? It did. So I'm going to store that work. I need to turn this into a 0. Chase, how do I turn that into a 0?
You divide by 2?
Dividing by 2 would turn it into a 1. I always use the 1s to make the 0s.
Then you times the second row by -2.
And add it to which row?
Add row 3.
Add it to row 3. So I'm going to grab that times row add command. We're going to multiply by -2. Row 2 gets multiplied by that, and we add it to row 3. Do we like the work that it did? We're getting there, aren't we? Now, take a look at this. Look at these ugly decimals that are floating around here. That's not very fun for us to work with, but does the calculator care? Not a bit. Okay, now we like that work, so I'm going to recall the store command. Hit enter. Now, if you haven't seen this before, this is actually pretty cool. This is why I wanted to do this problem this way. Is everybody watching? You will inevitably get to a point where you've got some ugly fractions to deal with. Now, that number, 0.6, we could think about that. I need to change that into a 1. What would I multiply by? I could do 1 divided by 0.6. That would work just fine. Or, watch this. Okay, I've stored this in A. I've got 6 of my 9 goals accomplished. I want to turn that into a 1. Is everybody watching? Hit the math button. The very first thing on there is the fraction. Change to a fraction. So watch what happens here. Notice the 1, 0, 0, the 0, 1, 0 the same. 0.6 is the same as 3/5. If I wanted to change 3/5 into a 1, what would I multiply it by? What is it, Zach? 5/3. 5/3. You can divide by 3/5. 3/5 divided by 3/5 would be 1. Or we never divide by a fraction. We flip that over and we multiply. Does that make sense? So I'm going to take this and I'm going to go back here and I'm going to find that times row command because that's what we're going to do. All we're going to do is we're just going to times that row by that fraction. So there's the times row command. Notice that it already has a fraction in there, so there's plenty of space. Here's what we're going to do. We're going to take row 3 and we're going to times it by 5/3. So we're going to go back here and we're going to edit. 5 divided by 3. I can delete that other stuff. What row are we multiplying? Row 3. Hit enter. Do we like the work it did? I do, and look at the answer. What's z at this point? Z is -2. Okay, now we like the work, so let's store that. Then all I need to do is use the 1 to make those a 0. Okay, I'm going to pick on Chase again for a second. I want to change that -8 into a 0. How do I do that?
We'll just change it back into fractions and then times it by whatever.
Yep, if you weren't comfortable working with the decimals, we could change it to a fraction. Or if I want to cancel out a -0.8, if I want to make that a 0, I'd add 0.8. Is that okay? So if I take row 3 and I multiply it by 0.8 and add it to row 2, wouldn't that make it a 0? Now, let's double check, make sure it actually works. Let's grab the times row add command. So you got to go back a little ways. There it is right there. And we're going to multiply by 0.8. Samantha, which row is getting multiplied? Third one. And we're adding it to what row? The second row. Okay, it's this command right here. That's a decimal, not a negative. Did it do what we want? It did. Store the work. And the last thing I need to do is I need to turn that -0.2 into a 0. Nathan, what am I going to add to -0.2 to make it a 0? 0.2. So I'm going to take that third row, I'm going to multiply it by 0.2, and we're going to add it to which row? Row 1. So I'm going to grab that command. So even though we've had to work with fractions and decimals and ugly stuff like that, take a look at this. We multiply by 0.2, row 3, add it to row 1, Does it do what we want? There's the answer. And what do we call this form again? Reduced row echelon form. I'm going to store the answer just so I don't mess it up. There we go. What's X? 1. What's Y? 3. And what's Z? -2. Write it as an ordered triple and you're done. Okay, these are the commands. So let me get rid of this. Make this a little larger. 1, 2, 3, 4, 5, 6, 7, 8 commands. Why were there 8? Why not 9? They already gave us one. Generally speaking, it's going to take 9 steps to reach those 9 goals. If they gave you one of them, it's only going to take 8. If they gave you 2, it's going to take 7. Yeah.
Are you going to have one this hard on the test?
I would say this is no more difficult than this. Okay, it'll be this or easier. Yeah. I did. Yep. Okay, so you can go back and watch it. All right. Any questions? Okay, if we yeah.
So for each step, how do you know which one to go to?
Because when you're putting it in this form, you get this one, and then you use that one to turn these into zeros. Then you get this one, and you make this a 0, and then make that a 0. Once you get the ones, you use the ones to make the zeros in that column. So 1, 0, 0. Make that 1, make these 2 zeros. Make this 1, use that to make those zeros, and then the answers will just be right there. Okay? Get the 1 first, then the 2 zeros. Get the 1 first, then the 2 zeros. Get the 1 first, then the 2 zeros. Good? Okay. Any questions? Okay, if we have time at the end, I'll go back here and we'll start right here, and I'll show you what would happen if we did this one right here. If we did instead, if we did the times row 3 by 3 and add it to row 2. You don't have to work with fractions that way, but the numbers do get a little bit bigger sometimes, yeah. You have to write down all those. Yep. So if you do it on the calculator, I want to see what commands you typed into your calculator. Okay. Which is a pretty good trade-off, because you write a couple of these things that does all the arithmetic for you. That's not too shabby. Okay, are there any questions? Sure? Okay. Again, raise your hand if you got done with 12.3. Okay. Raise your hand if you're half done with 12.3. Okay, that's not too bad. How many more sections are we covering? Only one. Okay, so let me make this straight. Okay, is everybody listening? Okay, we covered 11.3, excuse me, 11.2, 11.3, 11.4. We covered 3 conic sections: parabolas, ellipses, and hyperbolas. Okay? Then we covered this stuff right here, row operations, augmented matrices, solving systems, and stuff like that. That's 4 things that we've covered. Okay? And then we're going to cover one more. Next Friday, there are going to be 5 problems on the test. There will be a parabola, an ellipse, a hyperbola. Maybe it'll give you the equation, maybe it'll give you information and have you come up with the equation or something like that. There will be one of these, like we just did on the board. Okay, so you've got to know how to do that. And then I will put one partial fraction decomposition problem, which is what we're going to learn next. Now, of all the stuff that we've covered in this class, when you take 1050, partial fractions and solving augmented systems, those tend to be some of the toughest. Okay, so you're getting a real flavor of what some of the more difficult topics in 1050 are all about. Okay, now there are a couple things that we don't cover in this class. Okay, sequences and series. There are some other types of solving systems using matrices and stuff like that. But you're getting a real flavor for what 1050 is like now. Okay, are there any questions? Shane, do you have any questions? Other than, can I just go to sleep and ignore Mr. Laws? Very good. Okay, all right, I just passed out some notes to you, and they look like this. Would you take a look at those starter questions? And I'm going to give you about 2 or 3 minutes to figure those out. And I'll give you some little hints along the way if you're getting stuck on something. This is called the difference of cubes. You learned that formula in your 1010 class, and we reviewed it in this class. Difference of cubes. There's only one minus sign in the factors, and it always goes in the middle. The original one has a negative. It's in the middle of the first factor. This is a perfect cube of x, and this is a perfect cube of 2. So this is x minus 2. That's the first factor. And then the second factor is the tough one to remember. It's a perfect square of the first one. It ends with a perfect square of the second one, and the middle one is a plus, and it's just, anybody know what it is? It's just multiply the two of them together, so it's just 2x. Okay? That's the right factoring for that problem right there. No, there's only one negative in the factoring of these. And it's a negative here, so it's a negative in the middle of the two. Make sure you read the instructions for the next one. It doesn't say add them together. It just says what would the common denominator be. So that one's got an x plus 3. That one's got an x minus 1. This one has 2x minus 1s. This one needs something. In order to get a common denominator, we make them have the same denominator by making them have the same factors. So what does this one need? This one needs an x plus 3. Now, if I were going to add these, if I multiply the bottom by x plus 3, I'd have to multiply the top by x plus 3. What does this one need? Okay, it needs another x minus 1. It needs 2 of those. What else does it need? It needs an x plus 3 also. So I'd have to multiply the top by x minus 1 and x plus 3. And what does this one need? It needs both of those x minus 1. So it needs x minus 1 quantity squared. So the denominator here would be x minus 1 quantity squared times x plus 3. Okay, it just says what's the common denominator. There's the common denominator. We got that one. And let's take a look at this one. So this one was a little more complicated. There are 3 fractions to add together here. Here there are only 2. What does this one need? It needs an x plus 3. What does this one need? It needs an x minus 1 quantity squared. So the common denominator for this one is, well, I have an x minus 1 quantity squared and I have an x plus 3. Okay, now at this point, everybody stop, take a look up here. Look at these two problems. This one had 3 fractions and we got this denominator. This one had 2 fractions and we got, how do these denominators compare? They're exactly the same. So this one's going to make a difference as far as what the final answer is, but did this one have any impact on what the common denominator was? Nope, not really, because this one right here had 2 of these guys, so it kind of got that one taken care of. It was covered. Is everybody good there? Okay. This one says, now add the fractions in part B and simplify. So it wants us to go through and actually go through and do the addition. Okay. So for this, I just want you to follow along. Okay, the numerator here is going to be x minus 1 quantity squared, which if you remember is a perfect trinomial square. This is what it would be. This one's going to be plus x minus 1 times x plus 3. That's going to be x squared plus 2x minus 3. And this last part's going to be x plus 3. So these came from right here. These came from right here, and this came from right there. What do we do once we have all of these? you combine them all together. So I've got 2x squareds. Got those taken care of. There's a 2x and a plus 2x, so, or a minus 2x and a plus 2x, so those go away. I'm left with just a plain old x. And then the constants, I've got a 3 and a minus 3, and I've got a positive 1. So I've got that right there. And then the denominator is still x minus 1 quantity squared, x plus 3. What should I try and do with this? Should try and factor it, because then we might be able to cancel something. If you check this, multiply the first number and the last, or the first coefficient and the last number together, they multiply to be 2. Are there numbers that multiply to be 2 that add up to be 1? Nope. Nope, so it doesn't factor. That's the answer right there. Okay? Even though this one had the same denominator, it works out differently. So this is going to be x squared minus 2x plus 1. And then here we get x plus 3. So our answer on this one is x minus 1 quantity squared times x plus 3. And then the numerator, we've got an x squared, got that one taken care of. A minus x when I combine the two of those together, and I get a 4. Are there any numbers that multiply to be positive 4 that combine to be negative 1? There are not. So that's the answer right there. That's what we get when we add those together. Okay? Any questions? I'll review all stuff that you saw in 1010. We also worked with rationals earlier in this semester in college prep. So any questions there? Okay, my goal is to get through at least one of these problems. And you'll notice what we've got here is a bunch of lengthy stuff and then this ugly fraction right here. Okay, so let's run through this. This section is on something called partial fraction decomposition. So partial fraction decomposition. The phrase is almost as scary as actually doing the problems. That sounds ridiculously complicated. Partial fraction decomposition. But let's break that down. First of all, partial. What does the word partial mean? Half or not completely, or part. Okay, the root word there is part. Okay, we know what a fraction is. What does decomposition mean? What does decompose mean? Break down. Okay, so another way we could describe partial fraction decomposition is breaking down a fraction into its parts. Decompose means break down. So we're breaking down a fraction into its parts or its partials. Okay? So all we're doing is taking a fraction and breaking it down. Now that doesn't sound quite as bad as partial fraction decomposition, does it? Okay, so keep in mind that's what we're doing. We're breaking down a fraction into its parts. Okay, there are lots of different techniques for this. Okay, we're going to learn several of them. There are, on some of the easier problems, there are some shortcuts. But the shortcuts don't work unless you remember how they work and when they work. Okay, so I will show you that, and you still have to understand the basic process, how these fundamentally work. Okay, so we want to be able to solve any problem, so the shortcuts don't work on any problem, so we want to make sure we understand the underlying concept. Okay, we can only decompose fractions that are proper. Okay, remember what it means to be a proper fraction. A fraction is if it's improper, you can still decompose it after you do long division. Ooh, that's not good. Long division. Is that going to stick around? Excellent. Okay? So we can do long division. We don't have any like that in 1050. If you run into any of those would be if you take calculus or something like that. The main reason for learning this is extremely important if you take calculus. Okay? So any of you that want to go into business and have to take business calculus, or you want to be an engineer or something like that, this is a very important technique to know how to do. Okay? So the first step that we want to do in decomposing a fraction or breaking a fraction into its parts is we want to factor the denominator completely. Okay? You'll get linear factors, and sometimes you'll get what we call irreducible quadratics. Okay, now we talked about irreducible quadratics before when we were finding roots of polynomials, zeros and all that sort of stuff. Okay? That's a quadratic that doesn't factor. Okay? Okay, break the fractions into its parts. It may have come from based on the factors in the denominator. Okay, so one part for each factor in the denominator and one part for each of the repeated factors if necessary. Okay, don't worry about that right now. I'm going to show you what that means. Okay, place undetermined coefficients in the numerator of each of the parts. Okay, the degree of the numerator is always 1 degree less than the factor in the denominator. That's important right there. You're going to do that on every single one of these. Okay, the next thing we're going to do is we're going to clear the fractions in the equation. Okay, use an appropriate method to solve. Okay, Mrs. Cavan, if you take this from her, she calls these sweet numbers. Okay, I also call these convenient. Let me write it off to the side here. Blow this up just a little bit. Okay, I call these convenient zeros. Okay, so she calls them sweet numbers. I call them convenient zeros. We'll use systems of equations, and we'll use the Oliver Heaviside cover-up method. Oliver Heaviside is an actual person. How would you like to go through life with the name of Oliver Heaviside? You can look him up, Google Oliver Heaviside. He actually existed. It's named after him. It's a pretty cool technique, but you're going to understand why this technique works before we use it. And then the final technique, or final step, is going to be to rewrite the original fraction as the sum of its parts. Okay, please don't forget this. It's the answer to the problem. Okay, you're not done until you've taken the fraction, the single fraction, and broke it into the parts that it came from. Okay? All right, everybody ready? Okay, let's go ahead and do a problem. So here's the first thing. We want to factor the denominator completely. So we're going to take this problem and we just factor the denominator. Does that look familiar? What's that called? Difference of squares. So we're going to take this and we're going to write it as 3x. Ooh, let's see. Oh, I see. Hold on. Write it as the sum of a polynomial and a proper rational expression. So for this we need to do long division. So we're going to do x squared minus 1, 3x cubed, plus x squared. Anybody help me out here? No x's, save a place for the x's, and then this is going to be a 5. What do I multiply x squared by to make it a 3x cubed? 3x. So this is going to be 3x cubed minus 3x. And then what do I do? Subtract, or change the signs. So this is going to make a 0. This is going to make x squared. This is going to be 3x, and this is going to be plus 5. And then we look at the x squared and the x squared. What do I multiply x squared by to make it an x squared? Just a 1. So I put a 1 up here, and I multiply. So that's going to be x squared. That's going to be a minus 1. And then I subtract, or change the signs. So these go away, and that's going to leave me with 3x and plus 6. Can I multiply x squared by something to make it a 3x? Nope. Okay, so this has a name. Remember, it's called the quotient. And this is the remainder. And the answer is the quotient plus the remainder divided by the divisor. So it's going to be 3x plus 1 plus the remainder is 3x plus 6 divided by, what's the divisor? X squared minus 1. Okay. I forgot that you do have a couple problems like this on your assignment. So you have a couple easy long division problems to do. Okay, so that's how you do long division. Okay. Any questions? All right, now let's do one of these. Okay. So the first step in breaking this into its parts is to factor the denominator. So the first thing we're going to do is we're going to write this as x plus 1 divided by, if I factor the denominator, I'm looking for two numbers that multiply to be 6 that combine to be negative 5. Minus 3 and minus 2. Okay, so x minus 3 and x minus 2. Easy enough? Nothing new there, right? Okay, here's how you break it into its parts. For every one of these factors, or its repeats, we write another fraction. So I'm going to write one with a denominator of x minus 3 and one with a denominator of x minus 2. Good there? Okay, now, this is the part where it starts to get a little bit weird. It has this phrase that says, place undetermined coefficients in the numerator. The degree of the numerator is always 1 degree less than the factor in the denominator. So let's take a look at this. What degree is the denominator? It's degree 1, right? This is to the first power, and that's to the first power. So both of those denominators are degree 1. If the numerator is 1 degree less, it's got to be degree 0, which means it doesn't have an x on it. It means it's a plain old number. So what we usually put for this is a big capital A. These are the undetermined numbers that go in the numerator. Okay? If this is degree 1, this is going to be degree 0. It's going to be a different number, so we represent that with a B. If there were another one like this, guess what we'd put? A C, and if there were a fourth one, a D, and then a capital E, and so forth. Everybody good there? Okay, now, it's really important that you understand the logic behind this. What I'm saying is, this fraction had to come from two different parts. One part had an x minus 3 in the denominator, and one part had an x minus 2 in the denominator. Because they couldn't have ended up in the common denominator unless there was one of each of those. Does that make sense? Okay, this is an equation. All the way back, there are some people in here that were in my 1010 class. The very first day of 1010, I said, if we're solving an equation and it has fractions in it, do you have to work with fractions? No, you don't. So let's solve this by doing this. Let's get rid of the fractions. Most people don't like working with fractions, so I'm going to multiply by x minus 3 and x minus 2. If I multiply on this side by those two factors, what happens? They cancel out. What's left? X plus 1. If I multiply this term by those two factors, what cancels out? The x minus 3. What's left? A times x minus 2. Write down the rest. B times x minus 3. So, we took this fraction, we broke it into two parts, and then we said, you know what? I don't like working with an equation that has this many ugly fractions in it and stuff like that. So we multiplied by the denominators. It canceled it out. Here we're left with a plain old x plus 1. Here we're left with an a times x minus 2 and a b times x minus 3. Any questions? Okay. The first thing that we want to do next is we want to identify what numbers would be nice to plug in. Okay, Mrs. Cavan calls these sweet numbers. I call these convenient zeros. What's the 0 that comes from this factor? 3. What's the 0 that comes from this factor? 2. So, watch please. What if I let x equal 3 and I just plugged it in? Notice I've got an equation, but it's got an x, it's got an a, and it's got a b. So really it's got 3 variables in it. Can you solve an equation with 3 variables? Nope. This is why these are called convenient or sweet numbers. Because watch what happens if I plug in a 3. Let's plug in a 3. I get 3 plus 1. I get a times 3 minus 2. And I get b times 3 minus 3. What's this? 4. What's this? 1 times a. What's this? A times or b times 0. So that just goes away. Read this equation for me. 4 equals a. Didn't we just find the answer for a? We got it. We're all set. Okay. Now I'm going to change back to another sweet number. The other one was, or the other convenient 0 is a 2. If you plug in a 2, what's this side? A 3. What's this one? A times 2 minus 2. 2 minus 2 is 0. See why those are convenient? That's gone. And then I have plus b times 2 minus 3. So this is 3 equals, this would be negative b. So what's b? Negative 3. So up here we said, look, here's the fraction. I want to break it into its parts. We said its parts would be a over x minus 3 and b over x minus 2. Didn't we just figure out what those were? We did. So here's your answer. Your answer is 4 over x minus 3 minus 3 over x minus 2. There's your answer. That's it. We took this fraction right here. These are the parts that it came from. If you add those two together, or you combine those, and you can write it like this if you want. You can do plus a -3, or you can do the negative out front. If you combine those fractions, guess what you'd get? That right there. Okay? All we're doing is we're taking a fraction, breaking it into the parts that it came from. That's partial fraction decomposition. We'll pick up there tomorrow. Have a great day. And I'll get this video posted.